Hello and welcome to another MVP Cloud OS Week Online video. My name is Richard Astbury and I'm here to talk to you for about 30 minutes on Windows Azure. My Twitter handle is @richarama, so please feel free to contact me and ask me any awkward questions on that. I'm an MVP for Windows Azure and I work as a consultant across Europe, helping other software businesses understand what the cloud is and means for their business. But I tend to get practically involved in helping them move software from on-premises up to the cloud and get it running in Windows Azure. I like to get involved in tricky and interesting problems and working with odd technologies and things that don't necessarily fit that well into the cloud. Today we're going to compare some of the compute options in Windows Azure and look at the differences between websites, cloud services, and virtual machines, and we'll discuss these features and how they compare. We'll also very briefly look at things like the portal and discuss the management API. Then we're going to dive into some demos and look at how a Windows server can be quickly and easily provisioned from the portal, and then we'll look at how you can automate this and use a script to deploy a Linux machine. So what is Windows Azure? Well, basically Microsoft have a network of 12 data centers, 2 in China aren't shown here, that span the globe, which they use to host their own online services such as Bing and Hotmail and Office 365. Now these data centers also run Azure, which is the opportunity for you to host your software alongside the Microsoft properties and have the Microsoft Global Services team manage the infrastructure for you. The advantage here is that you can deploy to any of these data centers and have a global reach for your software, and you can pay by the hour or by the unit for any resource you consume. So if you switch it all off, there's no commitment, no ties, you stop paying the bill. But when you consume the resources, you just pay as you go for the pieces you need. So to start up a business very quickly or to try an idea out, it's a fantastic place to run software. What is a data center? Well, it's not just a few racks with a few servers in it. These are some pretty significant investments. Often they're container-based data centers with 40-foot shipping containers holding 2,000 servers each. These containers are then wheeled into a large warehouse and connected up to power and cooling and Ethernet. These are what form the basis of the data center. The hardware inside these containers will often fail, and when that happens, they're just switched off and not used anymore, which is an interesting point. Cloud computing is brought to you at a very low price, and that's because commodity hardware is being used here. So you can expect failure to happen, especially if you're running large applications consuming lots of resource. At some point, something will fail. So your software and your application needs to be resilient to this and handle failure and have retry logic and things like that. So what actually is available in Windows Azure? Well, in terms of running software, there's really 3 main options. There are virtual machines, which are an infrastructure as a service offering. There's websites on the far right, which are an extreme platform as a service, where you simply upload your source code and Microsoft hosts all that for you. And then somewhere in the middle, cloud services, which is where Windows Azure started. This is a kind of hybrid between the two, best of both worlds. It is a platform as a service, but you are able to customize the operating system to some extent. So you get some of the advantages of infrastructure as a service, being able to run your own scripts on the box and customize it, but in fact Microsoft are deploying the software for you. Let's quickly dive into each of these things, and then we'll focus a bit more on what the virtual machines are. So let's compare a traditional on-premises solution where you're responsible for all of the hardware, all of the network and operating systems and deploying your software and managing all of that, to a virtual machine in Windows Azure. In this world, you no longer have any responsibility for any physical equipment. You just get a virtualized image or a machine running, and you can then RDP or SSH onto that machine and go and install your software and set it up and configure it just the way you want. This gives you ultimate power, but you have to pay the price of having to update and maintain the operating system yourself. In cloud services, Microsoft take a little bit more responsibility. Yeah, you upload your software and then Windows Azure will unpackage that and deploy it across a farm of machines for you, and the Windows Azure Fabric will update the operating system when critical patches come out that need applying. So they take away some of the pain of having to upgrade the operating system and to deploy software. With Windows Azure websites, all you provide the platform is your code, and Windows Azure will even compile that for you and place it across some hardware. You have absolutely no control over that operating system, and websites only runs a small subset of technologies. Let's take a look at each of these technologies in a bit more detail. Let's start with websites. So a website does exactly what it says on the tin. It is just a way of running web-based applications on the Windows Azure platform. It should probably be your first port of call if you want to run something on Azure, as it's probably the quickest and easiest thing to get going with. You can deploy software using a variety of technologies, using Git and GitHub and Bitbucket, or TFS and the automation provided there, as well as services like Dropbox. So it's very easy to get your software on a website and get going. Websites runs a handful of technologies. It can serve static HTML, it can run classic ASP, it can run Python, Django and PHP applications, as well as, of course, Microsoft ASP.NET and Node.js applications too. So if your application uses one of those technologies, it's quite likely you'll be able to get part of it running in Windows Azure websites. There's also a gallery of extra web sites and pre-built templates you can choose from. So if you want to get a wiki running quickly or a blog, it's very easy to pick one of these pre-packaged templates and start from there. So that's websites. Moving on to cloud services, this has been the mainstay in Windows Azure since it was launched. And in this scenario, you package up your software in a particular format using some tooling built into Visual Studio or Eclipse, and then you upload that package to the cloud. Windows Azure then deploys that package across a set of machines for you, and as I said earlier, you can run some scripts at that point to customize the operating system if you want, to bring down extra dependencies or modify the software on the machine. You can run a variety of either web roles or worker roles, and you can mix the two, and you can scale each independently. What can cloud services run? Well, the saying is that anything that runs on 64-bit Windows could run on cloud services. We've certainly had success in running things like Node, Python, Erlang, COBOL, all kinds of unusual technologies. So it's not just a .NET cloud. If your software doesn't run in cloud services, then the fallback position is running things in virtual machines, which is what we're going to spend some more time looking at today. So virtual machines come with a variety of pre-baked templates for you, including machines with things like SQL and SharePoint installed already for you. There's also a set of Linux machines available to you as well. There's also a website called VM Depot, which hosts hundreds of extra virtual machine templates that you can pick and choose from and deploy those. So if you want to get going with a particular technology, you might find a virtual machine template in VM Depot that has that already pre-baked for you. So you just follow a few simple steps and you have that running. Because virtual machines are backed by the same or similar hypervisor to that used on on-premise Hyper-V, it's possible to migrate machines from an on-premises data center up to the cloud, and indeed from cloud to cloud and back down again. So there's definitely a portability story there. You're able to move machines around and take existing images and go and just simply upload them to the cloud. Virtual machines come in a variety of sizes, ranging from extra small as a shared core, but small as a single core with 1.75 gigabytes of RAM and 225 gigabytes of disk, and 9 cents an hour. And then you can scale up to extra large, which is 8 CPUs, 8 times the RAM, 8 times the disk, 8 times the price. So you simply pick on here where the best price point is for you. The A5, A6 and 7 are high memory options should you need a machine with a particularly large amount of memory. And of course, they're costed accordingly. Microsoft has done a great job with Windows Azure to try and make it as open as possible. A lot of the libraries, SDKs and tooling are not just available on GitHub, that's where they're actively developed. They're taking community contributions and pull requests and are very responsive on issues as well. So it's fantastic to see Microsoft developing their software out on GitHub like this. Azure is also an open platform and embraces a variety of languages. It's not just .NET. If your software is written in PHP, Java, Python, Ruby, Node, or of course .NET, you can take advantage of the libraries and SDKs and tooling around for you. It's also cross-platform in terms of the client machine you're working on. So you can, of course, use Windows Azure from a Windows machine, but you can also use it from a Linux or a Mac. Windows Azure comes with a nice HTML-based portal that you can use to monitor and manage your resources in the cloud, and we'll spend some time looking at this later on. What's probably more interesting is that there's a management API that backs this portal. So anything that you can do through the portal, you can also do programmatically using an API. And we'll have a quick look at how we can use this later on too. They're the basics of Windows Azure, but beyond those basics are a number of extra building blocks and pieces, services built on top of other parts of the platform that offer you some richer functionality and offer you the pieces that you can pull together and combine to accelerate software development or to build your own system. They solve common problems and use cases that save you from having to reinvent the wheel. I won't have time in this presentation to go through all of these, but it's just it's worth being aware that there are many other services available in the cloud, and we've just purely looked at the compute pieces here. Okay, so let's stop there and end the PowerPoint stuff, and let's actually go into the portal and go and request a machine to be stood up, and we'll go in and have a look at it. So let's fire up a new browser and go to manage windowsazure.com, and we can log in. Like this. And it shows us a summary of all the resources we have available to us. So let's go and create a new machine and see how easy and quick it is to get going with a new virtual machine. So with a new virtual machine, I've got two options: quick create, where I can just type in some details here, or from the gallery. So let's just have a look at the gallery very quickly. And this is the list of machines we saw earlier in my presentation. There's a few more available now, including Oracle and a machine with Java on it, and a few other pieces, as well as some machines that I've saved from before, so you can create your own images and store them in your portal for later use. Let's just go and create a quick Windows machine, and we'll just call it MVP demo RA or something, make it a bit unique, and put a password on there. And then at this point we get to choose which data center we want to deploy to. Now we could use from any of the data centers in the world, but let's go for a more local one and try and therefore reduce the latency. We can also choose which storage account we're going to use to store the data or the disks that they're going to back the machine, and we'll ignore availability set for now. It's checked that URL is available for me to use, so I can go in and pick which network ports I would like open, and by default it's set up a remote desktop and PowerShell for me already, which is good. So let's press OK here, and we're going to start provisioning. So what it's doing now is it's identifying the physical hardware for the machine, and it's getting the operating system template, and it's applying that, and it's bringing up a fresh virtual machine for me to log into. So I'll let this run for a little while and pause the recording so you don't have to watch the progress bar, and we'll come back when the machine's ready for us to log into. We've just enough time to go make a cup of tea. The machine has booted up and it's available here running now. After a while we should expect to see some statistics build up in the graph here about disk and processor usage, and we can dive into a few more of the counters on the box here to find out how the machine is performing and to diagnose any faults. We can see which endpoints are open on the machine, so which public ports are available, and we can go and configure some monitoring and other pieces here too. We can also adjust the size of the machine and scale it up to a larger size should we need it. So let's connect to the machine and see what we've got. We should download an RDP file here, which we can open, and we can enter the username and password we were entered in the portal, and we should connect through to our virtual machine here. So server manager is loaded. Let's get rid of that, and we can have a look at the disks on the box. Instead, we can see, surprisingly, there's a floppy disk drive. C drive is where the operating system is installed. There's a temporary D drive, which is a great drive to use for temporary files, because it's a drive located on the physical hardware that's running here rather than in a remote blob. So we should put temporary data here, but that may well be lost if the machine's rebooted or if it fails and is brought back up by the system somewhere else. So you can go and add more drives in the portal and attach them to the machine and store data on there, or you can go and install your own software on the C drive here. Now my machine is running in Windows Azure. I can go back to the portal. I can then go and attach a disk if I wish to the machine, which will then mount an extra drive on the Windows server. I can also shut down the machine, and once it's shut down I stop paying the bill. I could also sysprep that machine, which would give me the ability to then create an image from which I could then create new machines, taking that image as a starting point. So if I perhaps wanted to install my own software on there, I could take that as an image and a starting point for then deploying more instances based on that, rather than the stock images provided by Microsoft. So hopefully that was a useful demonstration of how a Windows machine can be quickly created from the portal and accessed over RDP. It's quite straightforward and quite quick to get something going. Of course, when we're finished with that, we can just delete it and we stop paying for it, or we can stop it and start it again later. But one of the main advantages of the cloud is that these things can be automated, and the Windows Azure is a programmable infrastructure, so we can write script or code which goes and creates resources for us, saving us having to go and manually stand up lots of resources in the portal. So let's have a quick look at a Linux box I've got running locally here, and I've got a Python script which we can have a very quick glance at. I won't go through the details of it, but this script goes and creates all the resources required to stand up a virtual machine. completely automatically, and then will let us know when it's ready. So let's try this out by typing the name of the script, and then it just wants a name that it's going to use to name the machine. So we'll call it RA MVP Demo 2. So now it's gone and created an affinity group, which is a useful way of connecting together various resources like virtual machines and storage accounts, so that when Azure provisions them, it provisions them in a sensible way so that they're not too far away from each other in the data center. So we get a lower latency when we access the disk on the machine. So now it's creating a storage account for us, and this takes a minute to do. There we go. Now it's creating a hosted service which will home the virtual machine. It's adding some certificates that I'm going to use to SSH onto the box, and we can see it's sent this blob of XML up to the management portal to go and create the actual machine itself. So we should it should take us a few minutes here, so I'm going to pause the recording again, and when it's finished we can resume and have a look around on the box and see what's going on. After another short interlude, we're back, and we have successfully deployed the machine to Windows Azure. So now we can SSH onto the box and check that it's there. Just enter my password, and there we are. We're on a Ubuntu machine in the Windows Azure cloud. I hope this session has been useful and given you a good introduction into what Windows Azure is. In summary, we've compared the various compute options in Windows Azure, and we've looked at the differences between Windows Azure websites, cloud services and virtual machines, and contrasted the platform as a service features against the infrastructure as a service options. We've discussed some of the other Windows Azure features, including the management API, and we've looked at the portal, and we've seen a demonstration of how Windows Server can quickly be provisioned through the portal. We've also seen how a Linux virtual machine can be provisioned automatically using a script, and how Windows Azure is a programmable infrastructure. I hope it's been useful, but please feel free to contact me on Twitter @RichardArmour if you have any questions following this session. Please visit the CloudOS website and find out more about the MVP community on the links provided here. Thank you very much.